Hello all, this is the Chapter 10 review for circles. Let's start with number 1. It says AD and CD are tangent segments. Find angle D, so this is what we're looking for here. If ABC is in a ratio of 7 to 5 with AC. So this would be 7x, 5x, causing you to get a ratio of being set up. What do you know a circle equals? Well, 7x plus 5x would equal 360. Or 12x equals 360. So x ends up equaling 30. What you could do then is you can plug it in. You can say, if I plug it in here, this is 150, and this is 210. We want angle D. So what I would do is, because these are tangent, I know they're congruent. We know that the minor arc and the exterior angle to a tangent has to add to equal 180. So if we do 180 minus 150, we get 30 for angle D, which is your answer to number 1. Number 2, a chord length of 48 is 10 units away from the circle. Let's start by drawing ourselves a picture. Center of the circle. We'll draw on a chord. We know that's 48, and we got 10 units away. Well, you could draw any radius to the center of the chord, breaking it up so that 48 would break up into congruent pieces of 24 and 24. We need to find the circumference in area. So what I would do is I would draw in my radius. This is what we're looking for. We'll call it x. And you can do Pythagorean theorem to figure out the missing side. Otherwise, this is a 5, 12, 13 multiplied by 2. So if you don't do Pythagorean theorem like I was saying, because it's a 5, 12, 13 multiplied by 2, x ends up equaling 26, which is the radius. Now I could find the circumference, which is 2 pi r, which gives you 52 pi. And the area is pi r squared, which gives you 676 pi. Questions? No? Let's proceed on. Question 3. A circle of radius 25 has a chord length of 48. So we'll draw ourselves another circle. We have a chord length of 48. We have a radius of 25. We want to know how far from the center is the chord. There it is. Similar picture as above. So the 48 breaks up into 24 and 24. Well, when we look at it, you could do Pythagorean theorem, or no, this is a 7, 24, 25 right triangle. So it's 7 units from the center of the circle. Number 4 can be done in 2 ways. I'm going to use our new power rule to be able to answer this. So I'm going to continue to draw the secant to the edge of the circle. Stopping at the center is not a secant. I'm going to do my rule. This is a tangent secant rule. So to use the tangent secant rule, the tangent says you take it and you square it. The secant rule, I'm going to call this piece x. So the secant rule says the whole thing, which is 8 plus x, times the outside, which is 8. And now I'm going to figure this out. 144 is equal to 64 plus 8x. Subtract it over. 80 is equal to 8x. So x equals 10. Well, let's look at the circle. 10 equals the diameter of the circle. So then what can we do? We can say that the radius is equal to 5 because it's half the diameter. And now we can find the area like we want, because area is equal to pi r squared, which ends up being 25 pi units squared. 5, 6, 7, 8, 9, and 10 are all a big circle. All we have is the marks of 50, 70, 60, 40, 110. Add them all up. Subtract it from 360. ends up with that arc AB is 30. H is the center of the circle. From there, we can say DAF, DAF, this angle right here. So this one's on the circle. So what do? We look at the arc it opens to, which is right here. That arc is 1 hundo. So we take a hundo divided by 2, and the answer is 50. In 6, we're looking at angle DHB. DHB. DHB is the center of the circle. At the center is just the arc it opens to. So this is center. So we see it opens up to the 50 and 70. So your answer ends up being 120. Number 7 is angle G. Angle G is located outside the circle. So we find the big arc. The big arc opens from D to A. So we add all that up. That's 150. So we take 150, because it's outside, we subtract. 40 is the minor arc right here. We divide by 2, and we get our grand total of 55. DKE for number 8. DKE is here. It's in the circle. It opens up to 2 arcs. The arc it opens to is over here, which is 60. The other arc is its vertical angle, which is 30. You add those 2 up and divide by 2, and you end up with 45. Angle J is located outside the circle. Angle J, the big arc opens up from B, travel all the way around to D. So the big arc ends up being 240. You subtract 70, that's the minor arc right here, divide by 2, end up equaling 85. And last but not least, to the big circle, we got A, D, J, which is here, which is on the circle. So it's half of what the arc it opens to. So the arc it opens to goes from A to D. You add that up, you have 150. 150 divided by 2 equals 75. Make sure you know something like that, because that'd be a 10-point question tomorrow. Number 11, you have 2 concentric circles. That means one circle's inside of the other circle, and they share the same center. We got one radius of 8, so we'll say the minor radius is 8. The big radius goes to the edge of the chord AC, so that is 16, and we want to find the outside. So you could do Pythagorean theorem here, and we have 16 squared is equal to 8 squared plus x squared. Okay, end up with 256 minus 64 plus x squared. Bring it over. 192 is equal to x squared. You root it. X ends up equaling 8 root 3. So this piece here ends up being 8 root 3, which means this piece has to be the same. So for AC, our answer would be 16 root 3. What do we notice now? Now what do we notice is that this triangle right here ends up being a 30, 60, 90. So this angle is 60. This angle ends up being 30 up here. We want to find the measure of AB. AB is right here. Well, AB is congruent to AC because we know the arcs are the same. So if we notice, if we finish drawing this over here, this angle would be 60, which is central angle of 120. Central angles cause that, so this arc would be 120. If I drew the triangle on the opposite side over here, this arc would still be 120, which means that the measure of AB equals 120. And last but not least, we want to find the length. Remember, length is not a measure. It's an actual using the circumference. So if we want DE, all right, we'll do a different color. So if we want DE right here, we need to figure out the measure of that. Well, if that's 60, this has to be 60. So the measure of the central angle for DE is going to be 120, but that's over 360, and then you have to multiply by the circumference, which is 2 pi, and the small radius ends up equaling 8. So what do we get? We get 1/3 times 16 pi. Well, does 1/3 go into 16? So you got 16 over 3 pi for the length of DE. And last but not least, on page 1 is number 12. What does number 12 look like to you? Hopefully you noticed they'll walk around. We know AB ends up equaling 7, AC is 11, and BC is 10. Our goal is to find the radius of angle of uh, circle A. So we'll start with that these are congruent, and these spots are congruent. So what do? We say this is x, so this is x. This is 7 minus x, which means this is 7 minus x. Over here, we get 10 minus, and don't forget to put in parentheses, 7 minus x. Distribute the minus sign to both. We get 10 minus 7 plus x. So this simplifies to 3 plus x, which means that this piece here is also 3 plus x. Now we're done because we stopped because we're back to x. But what we do know is that this side over here, let me highlight it, this side over here is x plus 3 plus x, and you're going to set that equal to 11. When you simplify this, you get 2x is equal to 14, so x ends up equaling 7. I'm sorry, you subtract that over, so you get 8. Silly me. And 2x is equal to 8, so you divide by, and you get the radius of that is going to be 4. Number 13 doesn't have a picture, but what you notice is that a parallelogram is inscribed in a circle. When a parallelogram is inscribed in a circle, what shape do you make inside? If you said rectangle, you are correct. So we'll draw a rectangle inside of here. What sides do you have? You have sides 4 and sides 7.5. You want to find the radius of the circle. So what do? You draw on the diagonal, and what formula do you know is going to happen? You're going to use Pythagorean theorem, and you're going to say the hypotenuse right here is x squared, which is equal to 4 squared plus 7.5 squared. You do the math here, and you get that x is equal to 8.5. Well, what is x? What is that missing side? That's the diameter to the circle. So the diameter is equal to 8.5. You want the radius, so what do? You divide by 2, and the radius ends up equaling 4.25. Number 14, now we're starting to get into the 10.4 stuff, which is two circles are externally tangent, and you're finding a common externally tangent. Well, if the two circles are externally tangent, that means they're just touching each other. One radius is 12, one radius is 8. So we need to find this blue chord right here, which is the common external tangent. So what you do is you draw a line connecting the center of the two circles. They don't give that to you, but you do notice that this is 12 and this is 8, so the whole thing ends up being 20. Draw in the radii to the edge of the common tangent, 12 and 8. These are right angles because it's a radius to a tangent. Shift that line down to the center of the smaller circle, so this gets shifted down to here. Do not go up into one of the corners, just go across. Remember, I've told you and I've stated a number of times, and here's hopefully the last time I can state it, the right angle is never going to be at the center, so the right angle has to be here. We have this side of 20. Well, if this is 8, that means this piece over here is 8. The whole thing was 12. If that's 12, that means this piece down here ends up being 4. Now what are we going to do to figure out the length of the common external tangent, which is this side right here, is Pythagorean theorem. The 20 squared is the hypotenuse is equal to 4 squared plus x squared. Well, when you simplify that and you bring it all over, you got 4 hundo minus 16 plus x squared Bring it over, you get 384. Root it, breaks up into 8 root 6 for your answer. The next question says the distance between the two circles is 8. So if the distance between the two circles is 8, because it doesn't say center to center, but you can connect center to center because one radius is 7, the other radius is 5. So the whole length between the two, if you add it up, ends up being 8 plus 7 plus 5, which is 20. You want the common internal tangent, so let me make that our blue line again. So that goes from the top to the bottom. You take that line, you shift it, you draw in the radii first, so you connect them here and here. That's 7, that's 5. You take that line, you shift it to the center of the smaller circle, which means now the angle completes there. We said once again, the right angles are never at the center, so the right angle's here. This side's 20. This side was 7, but you shifted it up 5, so that makes this side end up being 12. And we want to find the common internal tangent. So we can do Pythagorean theorem of 12 squared is equal to 20 squared plus x squared. Or no, this is a perfect 12, 16, 20 right triangle. So the missing side ends up being 16 of what we're looking for. Continuing on, number 16 is a picture. This arc is 32, this angle is 51, and this arc is 28. We want to find AE and angle C. Well, angle C is outside. To be able to get angle C, we need big arc minus small arc. So we need this arc first, so we'll call it X. How do we get it? Well, 51 is inside. If it's inside, the inside rule says take arc and the opposite arc, add them up and divide by 2. So we're going to have 28 plus X divided by 2 equal it to 51. You solve, you multiply by 2 over, you end up getting x equals 74. So arc AE ends up equaling 74. If you want angle C, we said angle C was outside of the circle. So the outside rule is big arc, which is, this is 74. So you take 74. You minus minor arc, which is 32. You divide by 2, and you end up getting 21. So the measure of angle C is equal to 21. 17 is our new stuff, which we learned from 10.8. This is the chord rule. All right, the chord rule said piece times piece equals piece times piece. So what do we get? We get 7 plus x times x equaling to 7 minus 5 times 3x. Distribute x squared plus 7x. Distribute 3x squared minus 15x. All right, let's simplify, bringing the x squareds over and the minus 7 because it needs to equal 0. So we get 2x squared minus 22x. This is where it's tricky, where some of you might have a problem trying to FOIL this. To factor this. So the first thing is to see what they have in common. They both have a 2x. So if I take that out, I'm left with x minus 11. Now it still equals 0, and now I factored it. This answer is 0. This answer is 11. But this piece is called x. Can x equal 0? No, because it wouldn't exist. So the answer that we're looking for x is 11. The next question, BD ABD is 20 minus 2x. GD is x plus 90. And angle E is 5x plus 225. Well, angle E is located outside, so we can use our outside rule, and these two are the arcs that are given. So let's see what we have. Our rule says 20 minus 2x, that's the first arc. We minus the second arc, x plus 90. Notice what I did up there. This is over 2 equals 5x plus 25. What I'm just trying to point out is that this needs to be in parentheses because this minus sign needs to be distributed to both. So what we're really doing is 20 minus 2x. I'm minusing x, minusing 90, and I'm putting it over 2, equaling 5x plus 225. Multiply by 2's to get rid of it. Simplifying the math, we get 20 minus 2x minus x minus 90. This side over here ends up equaling 10x plus 450. Simplifying, you get negative 70 minus 3x equals 10x plus 450. Let's say we add the 70 this way. You're ending up with 520, minusing the 10 that way. X, you get negative 13x, divide by negative 13, and x ends up equaling negative 40. You want the arc AFG. AFG would be this arc right here. Well, if you can get these two arcs, then you can plug it back in and get that arc that you need. But you plug it back in, negative 40 here, this arc is 50. Plug in negative 40 here, negative 40 times negative 2 is 80. 80 plus 20, that's 100, so that's 150. So you take 360 minus 150, and the measure of arc AFG ends up equaling 210. The next question, we see that this is a tangent over here, and this is then an outside angle over here. We also know that these are vertical, so they're congruent. So let's mark our picture. EFG is 210, and we know the ratio of this is 7x to 3x. We want this arc right here, CD. Well, if that's 210, we can figure out that this arc over here is 150. Now we're stuck unless we remember that the minor arc and the exterior angle for a tangent-tangent rule has to be supplementary, so this is 30, which means that angle's 30. That's outside the circle, so that makes the big arc, which is 7x, minus the small arc, 3x, divided by 2 equals the outside angle of 30. Simplified over, we get 4x equals, because you're going to multiply this side by 2, 60. So x ends up equaling 15. And we were asked for arc CD, which is 3x. So when we get the measure of arc CD ends up equaling 45. Hopefully this is all making sense to you and you're cruising right along. Number 20. We are in our power theorems again. Let's solve for x. It's in a chord piece. So I notice 2 times x is equal to 3 times 4. So 2x is equal to 12. So x equals 6. That's good. The other one, let's do a different color. We got a secant rule. Secant says the whole thing. So 8 plus 4 plus 3, that's 15, times the outside, which is 8, equals to the whole thing down here. That's 10 plus y times the outside of 10. You do the math, you solve, you get 120 is equal to 1 hundo plus 10y. Subtract it over, and y ends up equaling 2. 21. We see a chord, but before we can do that, to get y, we need to get x, and x is a part of a secant, which is connected to a tangent. So for that, we can say this is a secant, this is a tangent. Well, what do you notice? That the secant is 3 plus x plus 5. So that's 8 plus x times the outside of 5 equaling the tangent, which is 10 squared. That's a hundo. 40 plus 5x minus the 40 over 5x is equal to 60. So x ends up equaling 6. Now we know that this piece is 6 instead of x. Now we can do the chord rule and say 6 times got 6, so 6 times 9 is equal to 3 times y. And you do the math, and then y ends up equaling 18. 22 is one of the more challenging questions, but it's just because you have to factor. Here's x plus 8. That's a tangent, so that rule would be x plus 8 squared equal to the whole secant. The secant, well, 3x squared minus 7, and we're going to add 4 to that. Well, 3x squared minus 7 adding 4, these combine to give you negative 3. So you're getting 3x squared minus 3. And the outside piece is 4. This you have to FOIL, so you write it out twice. You get x squared plus 16x plus 64. You forget the FOIL, you lose the middle term. This side is 12x squared minus 12. All right, bring everything over this way, giving you, when you subtract it, 11x squared minus 16x minus 76. Now you have to factor with the leading coefficient greater than that. So you multiply those two, and you get 11 times the 76, giving you the, negative 8, 36. But multiply, it adds to negative 16. You break up your two middle numbers. The 11x squared came down here. The negative 76 comes down here. You get, negative 38x and positive 22x. This group, you can pull out an x, leaving you 11x minus 38. And this group, you can pull out a plus 2, leaving you with x minus 38. 11x minus 38. So you get 11x minus 38 for one term, and the other term is x plus 2. This answer is negative 2. This answer is 38 over 11. And guess what? Both work when you try and plug them back in, because the negative 2 doesn't cancel out this time. 23, you have this wire that I'm drawing in blue around it. It's a strap that's connecting these pipes together. You do know that the diameter is 8, so if the diameter equals 8, the radius ends up equaling 4 because you divide by 2. So what you can do is you can draw a radius to the tangent connecting it. This makes a rectangle shape. These are 4, 4, 4, and 4. So this piece is 8. It mimics everywhere around because the circles do not change sizes. And then what we need to do is we need to find the measure of each arc. But this arc, and this arc are each 1/3. So what happens is that becomes one full circle. So you get 2 pi r, which ends up being, when you do the math of a radius of 4, you end up with the 8 pi. So doing the math, 8 plus 8 plus 8, that's 24. And you're adding 8 pi for the length of the strap around the pipes. The next one, you see that the length of the radius is 10. You see all 4 circles are the same. This is like an arts and crafts. You're trying to cut out these circles, maybe making smiley faces, flowers, I don't know, whatever you're into. You see the shaded region. So what we have to do is we have to take the rectangle. I'm sorry, that wouldn't be a rectangle. It says it's a square. Maybe I should read first. So you're going to take the square, and you're going to subtract the circles, the 4 circles. Okay. Well, what do we know? We know that the radius is 10. So we got 4 times pi 10 squared. Well, this is 1 hundo pi times 4. So that's 4 hundo pi. That's the circles. And the square we don't know. But we do know that radius of 10 and 10 and 10 and 10 make a side of 40, which means both sides are 40. 40 by 40 equals 1600. Subtract the 2, final answer 1600 minus 400 pi units squared. The last piece says find D to H. So find this little D to the center of circle H. So we can't directly find that. This is the one that I keep talking about, that garbage can question. What do? There's the center of the circle. So right here is what you can find. This makes a square shape because there's right angles everywhere. Each side is 10. So if you break it up, you know a square with sides 10 and 10. These are 45, 45, 90s. That's the, if you look at the 45, 45, 90, that's x, and x root 2. The side's x root 2. Well, if x equals 10, the side you're looking for is 10 root 2 from the center of the circle to D. Well, what do you then have to get rid of? Well, you have to get rid of this line right here. Well, what is that line right there? That's the radius to the circle, which is 10. So what do? You take the big piece, which is 10 root 2. You minus 10 from it. Can you do that math? Absolutely not. One has a square root of 2, the other one doesn't. So they don't have like terms. And you just leave your answer as that's the distance of that little line that's connecting right there. Finally, last but not least, and thank you for listening to this video. Hopefully you will do well on this test. I feel it is one of the most challenging tests, but if you know this review sheet, I guarantee you will get an A or a B or the grade you want or deserve on it because you've put in the effort for it. But otherwise, it's a lot of understanding the form and stuff. But if you've been keeping up with it, I think you'll be great. Two concentric circles, once again, that means they share the same center. One's inscribed and one's circumscribed around it. You know it's an equilateral triangle, so each one of these angles is 60 to begin with. You know that the circumference of the smaller circle, so the smaller circle has circumference of 20 pi. Well, we know 2 pi r is what the formula is, divided by 2 pi. Pi will cancel out, so the radius equals 10. I would draw on the radius, so that is 10. We need the radius of the big area of the large circle. Well, we learned from the previous question, from number 11, if you remember, that if this radius is 10, we know that this radius is 20, and I'm just going to use that because I know it's a shortcut to help me out. So now I can find the area of the large circle, which is pi r squared. We know that it is 20 for the radius, so you square the 20 and you end up with 400 pi units squared, and the first thing is done. We want the perimeter of ABC. Well, that's this right here. We know all the sides are the same, so if we can find this piece, we can do it. Hey, look at this. If that's the right angle, let's help ourselves out. That 60 broke up into 30 and 60. So this is a 30, 60, 90 triangle. If you don't remember the 30, 60, 90 triangle, across from the 30 is x, across from the 60 is x root 3, and across from the 90 is 2x. What you do is if that's 10, that means the x is 10 for this, so this side is 10 root 3, which means that the whole side length is 20 root 3, and you have three sides to a triangle, so the perimeter of triangle ABC would equal 3 times what one of the side lengths is, and you end up with 60 root 3. 2 down, 2 to go. The length of AB. Well, AB is here. We want the length of AB. We don't, we need the central angle, so we can draw this in here. Well, what happens is you draw this in, these are 30, so this is 60 and 60. So what we do know to find the length of AB, we can take the 120 over 360, and that'll never change. For those of you that like tricks and maneuvers like that, each one of these, because of the equilateral triangle, will end up being 120 apiece. So we got 120 over 360. We want length, so now we got to multiply by the circumference. We have 2 pi times the radius of the big circle, which we're looking for, because that's the one we want, is 20. What I end up getting is 1/3 times 40 pi, and does 40 go into 1/3? So we leave it as 40 over 3 pi for our answer. And last but not least, to finish it all up, hopefully it's going well once again, and you're not feeling too defeated, is that you want the distance from B to the smaller circle. So just like what we did up here, we want B to the smaller circle, this line right here. Well, to me, you can't directly find it, but we can find from the center to B. Well, the center B is the radius of the big circle. So we got the radius of the big circle. And then this piece right here, which I'll pick a different color, this piece right here is the radius of the smaller circle. And what can we do with those? We can subtract them, and we would have the distance on the outside. Well, the radius of the big circle is 20. The radius of the small circle is 10. This is one of the cases where they do have the same, there's no term on there. There's no root 2, so then one doesn't have a root 2. So can you do the math? Can you do 20 minus 10? You can do that, and your final answer would be 10 for the distance from B to the smaller circle. Well, good luck to you on this upcoming test. Hopefully you felt it went well, and we'll see you in class.